Good morning, guys. Anjani Kumar here, dealing power system 2 for third year electrical students. In a last session, we discussed about the potential distribution across the whole string. Across string is nothing but suspension type insulators, right? So what we discussed, so each and every disk, we are not maintaining uniform distribution of voltage throughout the string because of shunt capacitance existence between the metal conduct between the string and the pole. So due to that shunt capacitance, the voltage across each and every disk is not uniform, not constant voltage, equal voltage, that not that much voltage that we are getting. So that means what are the difficulties? Means the conductor, the disk which is nearer to the conductor, which is having more stress, that means more potential. So due to this, there is a chance of puncture or a flashover occur nearest to the conductor's disk. So if it is fails, so it will be gradually increases throughout the string will get stripped, right? So due to the shunt capacitance, if there is no shunt capacitance, so only the self capacitance existence between each and every disk, so the uniform current will flow. Due to that uniform current, the uniform voltage will appear across each and every disk, so that in that situation we don't have any problems. So the problem persists when a shunt capacitance existence only. So it is our duty to maintain the voltage uniformly each and every disk. So that can be done with the help of string efficiency. So what is the formula for string efficiency? So why we require a string efficiency means, so it is a phenomena which is used to maintain the uniform voltage at each and every disk of a string insulators. So how you can maintain it can be denoted by epsilon. So what is the total voltage across the string? Across the string by the number of disks in a string into multiplied by the voltage of the disk nearer to the conductor. So this is the string efficiency that we discussed in a last session, and we have taken some example how many disks that which is having 3 disks, right? So this is a conductor where the conductor is going to be twisted there. This is a cross arm and this is the pole. So the main effect is nothing but due to the shunt capacitance existence. Right, what is a shunt capacitance? It can be denoted by Kc. This is a self capacitance. So we can be denoted by C1. So we can call it as a C1. We can call it as a C1. Right, and we derived a formula. How many number of this total string voltage? If you assume that voltage V by each individual voltage V1, V2, V3. So total voltage across the string. How many disks? 3 disks, and voltage of the disk nearer to the conductor. What is this? What is that? So this is the efficiency. Alright. And in the last session we discussed about what are the formulas. We derived each and every formula. How you can find out the voltage V1, V2, V3 and all these things. So I'll write down what are the assumptions. So first assumptions, C1 is equal to K. So we are assuming that some constant K times the self capacitance, my shunt capacitance C1 is equal to K times the self capacitance. Right, that we assumption, first assumption. After that we apply a KCL at this point, we apply a KCL at this point. We derived in last session, no need to discuss about this one. So from that, what is the value of V2? V2 is equal to V1 into 1 plus K formula. Right, after that V3 is equal to V1 into 1 plus 3K plus K square. These are the formulas that we derived in a last session. I just want to brief rewind all these things, right? From that, what is a V1? V1 is equal to V by 1 plus K and 1 plus 3K. Right? V1 is equal to V by 1 plus K, 1 plus 3 plus K, right? So we derived in a last session, right? V by 1 plus K, 3 plus K. Alright, so from that you know the efficiency. So you know the efficiency. Efficiency is equal to total voltage across the string by number of disks, 3 into V3. You know the value of V, you know the value of V3, you know the value of number of disks. So you just calculate the efficiency of a string efficiency of that total string. But suppose if a string efficiency is increasing, that means you are increasing your string efficiency. Means, so what happened? Means you are maintaining uniform voltage across each and every string. So if you maintain efficiency is equal to 100%, means definitely each and every disk maintaining uniform voltage. So that's what we are requiring. But suppose if K value, K is equal to C1 by C. If K value is increasing, alright, if a K value is increasing, then what about C1? C1 is increasing. If C1 increasing, means the shunt capacitance is increases. If a shunt capacitance is increases, the main uniformness eppudu loss avutundi, means depends on a shunt capacitance only. Here your shunt capacitance is increasing. That means, so if a K is increasing, means your shunt capacitance is increasing. If your shunt capacitance increases, means you are getting uniform voltages across each and every disk? Definitely not. So what about the string efficiency? Your string efficiency is reducing. Got it now? So what is the main note that we discussed? Right? So if we want proper uniform voltage across each and every disk, if you not maintain that uniform distribution, means the conductor, the disk which is nearer to the conductor, which is having a maximum stress and goes on, the stress is decreasing. So there is a chance of failures near the conductor disk. Right? So if it is fails, the total string will, because that disk can carry the conductor, right? And the first node is that thing. And the second node is, so in order to maintain these voltages uniformly, we just go for a string efficiency. So what is a string efficiency? We discussed about what are the formula of each and every disk. If a string efficiency is increasing, that means you are providing your voltage across each and every disk is a constant. That means uniform voltage that you are providing, right? And third one is, if K value is increases, what about the string efficiency? If a string efficiency is going to be reduces. Why? Because if a K value increases, means K is equal to C1 by C now. If a C1 value increases, C1 is nothing but your shunt capacitance. If a shunt capacitance increases, definitely the uniformness is disturbed. We are not getting uniform voltages. So main cause of ununiform voltages means because of shunt capacitance. If K increases, shunt capacitance is increases, you won't get the uniformness. You won't get the uniformness means the string efficiency is reducing. So this is very, very important bit. And so these are the things that we covered in our last session. I hope it's clear, and each and every formula that I derived, and I'll write it down here. So better to remind all these things. Now today's session we are going to discuss about so methods to improve the string efficiency. Right? So methods to improve the string efficiency. Very, very important concept. Yes, we'll discuss it. It's very important concept. So definitely it is our duty to maintain the voltage across each disk is a uniform voltage. So that means, what about the string efficiency? We need to increase the string efficiency to maintain the voltage across each and every disk uniformly. That means if a k value, I already discussed about, if k value is increasing, so what happened? The shunt capacitance is increasing, we are not getting uniformness, my string efficiency is going to be reducing. So it's our duty to increase the string efficiency. If you are increasing the string efficiency, means you are providing uniform voltage across each and every disk. So how you can increase this, these string efficiency? We'll discuss right now. I hope it's clear. So why we can improve the string efficiency means we should maintain uniform voltage across each and every disk. So it's our duty. So then only we are having equal stress on each and every disk. So right. So this is a cross arm and this is a pole, right? And this is a right. So these are the shunt capacitance. These are the shunt capacitance. Those are existing, right? This is suspension type insulators. So this is the voltage across V1, V2, V3. So this is a C. So this is a shunt capacitor. How you are assuming KC. The first methods to improve. If you are taking longer cross arm, right? So if you are taking longer cross arm, that means this is a cross arm now. This is a cross arm. So this is a pole. See, if cross arm is too much longer, so what happened? This is increases. The distance between the string and the pole is going to be increases. If this is increases, what about the existence capacitance? The capacitance value the capacitance value will be very less. That means reduces. So you are decreasing your shunt capacitance. Means what about the string efficiency? That means you are increasing the string efficiency. I hope it's clear. See, taking a longer cross arm. Your cross arm is this one now. If cross arm increases now, you are increasing your cross arm. That means here you are placing your. So that means the distance between the between the string and the pole is very high. That means large distance. So that means what about the shunt capacitance? The shunt capacitance value will be very less. Right? If the shunt capacitance is less, that means what about the string efficiency? String efficiency is going to be increases. So that is the first method. So if you increases a longer cross arms, the effect of shunt capacitance will be reduces. That means C1 value reduces. If a C1 reduces, what about the K value? K value reduces. If a K value reduces, what about the efficiency? Efficiency is going to be increases. So this is the first methods to improve the string efficiency. I hope it's clear, right? Your first method to increase the longer cross arm. And the second method, capacitance grading. Right? So the capacitance grading. So what is a capacitance grading? That means now I'm not taking the equal strength of a capacitance. Right? Means equal value of a capacitance. I'm taking different values of a capacitance. For suppose, you know that Q is equal to CV. That means voltage is inversely proportional to capacitance. If the voltage is increases, your capacitance is going to be reduces. Right? How you can maintain the string efficiency increases by this capacitance grading means you are taking different capacitance. But suppose here the voltage test, it should be very high now. Voltage test is very high. That means you are taking a capacitance value very less. Right? If you are taking capacitance value is very less. From here, from top to cross arm, your capacitance value is going to be increases. Right? So then you can maintain the voltages balancedly. That means, per suppose, if the voltage is here 50 volts, that means you are maintaining the capacitance will be very less, 2 microfarads. Right? If it goes on, your voltage is going to be reduces. If it is 30 volts, you are increasing your capacitance 4 microfarad. If it is 10 volts, you are increasing your capacitance 6 microfarad. Like this, you are different values of capacitance discs that you are going to choose. So it's very best method. I hope it's clear. Capacitance grading means different values of capacitance that you are going to take. So if you take these different types of capacitance, you can maintain the voltage constant uniformly. How you can maintain means the conductor, the disc which is nearer to the conductor which is having high voltage. So that means you are taking less value of a capacitance, then it will maintain some voltage, right? Voltage increases, your capacitance is going to be reduces to make uniformness, and again the capacitance is going to be increases when flowing through the cross arm. So this is one type of methods to improve. If you are providing uniform voltage across each and every disc means you are increasing your efficiency. But one of the drawback is, so each and every time you are going to take different values of capacitance. It's not possible, right? And the conductor, which is the disc which is nearer to the conductor, which is having a less capacitance, so there must be a easy chances of a failure of that capacitance value. Right, so that is a disadvantage. It's very difficult to maintain in a string. Each and every disc is different type, means we won't expect each and every. So what is a suspension type insulator? In that suspension type insulator, each and every disc will exhibit 11 kV. Right? If you are changing your disc, you don't know how much voltage that can strengthen, how much voltage that can carry. So that's why it's a proper. We don't have a proper estimation whether this type of 3 disc which is equal to 33 kV, 4 disc which is equal to 44 kV, 6 disc is equal to 66 kV. So we have to tell. So whether you place a different types of capacitance, it's very difficult to tell whether the line carrying 66 kV, whether line carrying 132 kV, and all these things. So that is a drawback. Definitely, if you place a different types of capacitance gradings, you will maintain the constant uniform voltage across each and every disc. So if you are providing uniform voltage means the K value is going to be reduces. That means the string efficiency is going to be increases. So that is a one method to improve the string efficiency. And the last method you will see. Now you are seeing in your real life also the method that is called God ring. Very important. God ring. Right? So the God ring. So you are placing a God ring. So how you are placing means, this is a cross arm, this is a pole, and this is a capacitance, and this is a conductor. Right? So these are the shunt capacitance, right? So if you want to improve the capacitance, the first thing is to reduce your shunt capacitance. ఎప్పుడైతే నీ shunt capacitance తగ్గిపోతుందో, eliminate చేస్తావో, then only the voltage across each disc will be equal. So for this, the third option is to provide a God ring. So God ring is nothing but here one metallic sheet is there, na? So for this, your conductor is going to be connected, right? So you are placing one metallic strip like this. You will see now each and every transmission system, you will see, definitely you go there and you see these type of god rings that can be placed. So like this they will place a god ring, right? So this is a string, this is a metallic strip. So there must be, air is nothing but medium, so there will be a chance of capacitance existence now. So how here we can expect the capacitance, here we can expect the capacitance, right? And here you can expect the capacitance, and you can extend this one. Here you can expect the capacitance, right? So we are providing one metallic ring, so that we can call it as a god ring for a metallic sheath, and whatever it may be, a cross arm, or it can be tied to the insulator, whatever it may be, right? You just providing one metallic ring, so that we can call it as a god ring. So while you are providing these type of rings, so this is a capacitance will be exist between these two now, because this is a air is a medium now, and two metal conductors, insulator and one metal and another metal. So between two metals, one the electric medium is air, so the capacitance will be exist. So here the capacitance will be exist, here the capacitance will be exist. So whatever the current that can be flow here, the same current will be flow here in a reverse direction. So what about these two currents will be cancelled out. That means whatever the capacitance, these two capacitance will be cancelled out. So here also the same current and the same current will be flow like this, and these capacitance will be cancelled out. The same current will flow, the same current will flow. These capacitance will be cancelled out. That means what you are doing means you are neglecting, you are removing the shunt capacitance with the help of these god rings, right? So with the help of these god rings, you are removing the shunt capacitance, means the shunt capacitance is going to be removed. If the shunt capacitance removed, means only the self capacitance will be exist. So if the only self capacitance exists, means the current flowing through the self capacitance is equal. So that means the voltage across each string is equal, because you are removing the shunt capacitance by providing one metallic ring, so that we can call it as a god ring. This shunt capacitance is going to be cancelled out with the help of imagination capacitance present at the god rings, right? So in this way we can maintain the voltage uniformly at each and every disc. So we are providing uniform voltage across each disc. That means you are increasing the string efficiency, right? So this is one way. I hope it's clear. You will see your transmission system, you will find these type of god rings on the bottom of a string insulator. If you want, you just go through the transmission lines for a 132 kV or a 66 kV. You will see these type of god rings placed on the bottom of insulators, right? If anyone wants, they will go and see that god rings. Alright. So these are the three methods to improve the string efficiency. So why we can maintain the string? Why we can increase the string efficiency means you are increasing your string efficiency, means you are providing the voltage across each disc is a uniformly. So why we need to maintain the uniform voltage across each disc means if we are not provide that disc which is nearer to the conductor, which is having a high stress, so definitely the high chances of a failures or a punctures that across are nearer to the conductor disc. So if it is failed, the total suspension insulator will get damaged. So in order to avoid these things, so you have to maintain a proper equal voltage, uniform voltage across each and every disc. Right? So why the voltage changes means across the shunt capacitance. If the existence of a shunt capacitance between the string and the pole, the main cause for non-uniform distribution is a shunt capacitance. So try to remind this one. That's why I'm repeating each and every time, because that is a stressful point. So the main cause for non-uniform distribution is due to shunt capacitance. Alright, so what are the methods to improve the string efficiency means? the first method is taking a longer cross arms, right? You are taking a longer cross arm means your shunt capacitance is going to be reduces. Your cross arm increases, so your shunt capacitance is going to be reduces. That means your shunt capacitance reduces means the K value is going to be reduces. That means shunt capacitance reduce means you are providing somewhat uniform voltage across each and every disk. So if a K value reduces, your efficiency, string efficiency is going to be increases. Alright, and the second one is a capacitance grading. So it's not possible to increase a longer cross arm, right? It is a cost based issue and some sort of drawbacks is there. So in order to avoid this, we are providing capacitance grading at a different capacitance that what you are going to choose. So if it is a voltage high, so in order to provide this one, the capacitance value will be reduces, and the bottom you are taking a less capacitance in order to maintain high voltages, right? And goes on, the capacitance value is going to be increases. So for this, the capacitance and voltage are inversely proportional. So with this, you can maintain the uniform voltage across the each and every disk. But what is the drawback means different capacitance. It's very cost based issue, and definitely we won't expect. If it is a string insulator, you have to check how many disks are present in the system. If there is a 3, so there is a 33 kV line and the conductor carries. If it is a 66 kV line, the conductor carries. So with this capacitance grading, you won't tell whether this is a 33 kV, whether it is a 66 kV, and all these things. Alright, because the capacitance are different graded, right? The disks are different. Alright, so you won't tell whether each and every disk, you won't directly tell each and every disk carries 11 kV. Right, so that is about the capacitance grading, advantages and disadvantages. The most efficient methods to improve the string efficiency is God ring. So what is a God ring? So God ring, why we need to maintain the God ring? God ring is nothing but one sort of metal wire which is connected between the metal sheath where the conductor is going to be connected and to the cross arm or insulator, that's your wish. So while you are providing these things, what about this? There will be a capacitance will be existing between the metal and another metal is there. So between these two, air is a medium, and we will get some sort of capacitance like how the shunt capacitance existence. Alright, so when these type of capacitance existence, whatever the current that can be flows to the shunt capacitance and the metallic capacitance should be the same and opposite. So these two currents are going to be cancelled out. So if the two currents are cancelled out, whatever the current, that means these two capacitors are going to be ineffective. Similarly, these two capacitance ineffective. Similarly, these two capacitance ineffective. By this processing, what you are doing means you just eliminating, you just removing the shunt capacitance. If you are removing the shunt capacitance means whatever the current that can be flow through the string which is a uniform. So if the current is a constant, that means the voltage across each and every disk is a uniform voltage. So you are providing uniform voltage means what about the string efficiency? Your string efficiency is going to be increasing. So that's why we are placing a God ring at the bottom of a metal sheath. Alright, you will see in your real life also. If you want to, you can go and see that God ring, how they are placed, the God rings, the bottom of suspension and type insulators, right? You will directly see. So these are the methods to improve the string efficiency. And one important things that we need to remind is very, very important. I'll write it down. The first point, if K value is increases, definitely we'll go take question. If a K value is increases, what about the string efficiency? String efficiency reduces. Right? So from this K is equal to C1 by C na. K increases, C1 increases. C1 increases, your shunt capacitance is increases. If a shunt capacitance increases, unequal will be built up. If unequal build up, your string efficiency reduces. And the second one, if non-uniform present, the conductor the disc which is nearer to the conductor, nearer to the conductor will have maximum stress. Very, very important. And after goes on, the stress will be reduces. And the third one is whatever the string voltage always consider phase voltage only. Very, very important while doing the problem itself. They will give the line voltage, you have to convert it as a phase voltage. That's right. The voltage, that is nothing but total voltage of a string is V na, so that is a V phase voltage. So if the line voltage is given, what is the relationship with root 3 into V phase? So from this you will get V phase equal to VL by root 3. So what is this voltage? A string voltage. Right? Always your string voltage will be the phase voltage. Right? So if it is a line voltage given, and that means line voltage means line to earth anamata. So if it is a line voltage given, what is a string voltage means you have to calculate. In order to calculate the efficiency, you have to do total string voltage by N into V3 na. So this is a phase voltage, not the line voltage. If you directly put that line voltage, definitely you will get wrong answers, right? So while doing the problem, we need to consider these things and discuss the formulas also while doing the problems, right? In the next session, we'll start the problems, right? So what are the formulas that we need to consider? Means the first formula is formulas. The first is K is equal to C1 by C. So C1 is a shunt capacitance, C is a self capacitance. Alright? And the second formula is, so what is a V1? V1 is equal to V by 1 plus K, 3 plus K. Very, very important, right? And we already derived all these formulas, but I just want to give brief things while doing the problems itself, right? So what is V2? V2 is equal to V1 into 1 plus K, right? And the fourth one, so V3 is equal to V1 into 1 plus 3K plus K square, right? And if they want line voltage means root 3 into V phase, right? And sixth one, what is the efficiency? Total voltage by number of disc and voltage, which is maximum you will get 3 discs only. More than 3 it's very difficult to calculate. This is for 3 discs voltage across each and every disc, right? So these are the different formulas that you will get while doing the problems itself. So this is about insulator concept. In the next session we discussed about problems in a string efficiency. In a problems, how you can calculate the string efficiency and what is a string efficiency and all these things that we discussed. So till now we discussed about what is the definition of insulators, right? What is why we require insulators, right? What is the mechanical properties of insulators, and after the different types of insulator we discussed about what is a pin type insulator, what is a suspension type insulator, what is a strain insulator, and what is a Schockel insulator, egg insulator is there. That all the insulator we discussed in detail, right? With diagram, with graphical representation also. So we'll get a clear idea while seeing that this type of insulator is a string insulator, right? This type of insulator is a pin type insulator. We'll get an idea. That's why I deal with a graphical representation itself. And after that, what we discussed about potential distribution between each and every disc on a suspension type. There is a chance of pin type insulator. We should maintain the safety factor in order to avoid the damage of this pin type insulator. For a suspension type insulator, we need to provide the voltages across each and every disc must be equal. So how you can maintain with the help of string efficiency? How can improve the string efficiency means There are three ways to improve the longer cross-arm, capacitance grading, and chord rings. So these are the different methods to improve the string efficiency, and these are the formulas to solve the problem related to string efficiency. So thank you for now. In the next session, we discussed about the problems related to string efficiency. Thank you very much.